Okay, sorry about having this be in two videos. There's kind of a technical error, I guess, when I had to pause for a little bit. But anyway, we are asked to convert the result from our previous question into miles per hour. So we have negative 188.976 feet. And I'm sure you've done this before, per 1 second. So we convert that. How many seconds are in an hour? 3,600 seconds in 1 hour. And then we need to convert miles. So there are 5,280 feet per 1 mile. And if we calculate all of that out, we get, hopefully you can trust me, about negative 128.847 miles per hour. And of course you could write it as mph. That's also correct. So, continuing with this problem, as this person hit the ground, they rebounded straight into the air with a velocity of 80 feet per second because of the squirrel suit. How high did they fly into the air on the rebound? Well, we know that at v of 0, it's going to be equal to our c, so we're setting time equal to 0 when they hit the ground, and at that point in time, it's equal to 80, right? Well, v of t, we know is going to be negative 32 t plus 80. So we can set that equal to 0 and solve here. So we get negative 32t is equal to negative 80. We're going to get t equals 80 over 32, which is equal to 2.5 seconds. Okay, so that's our time there is at t. And we need to actually find our position because we're saying how high did they fly into the air. So s of t is going to be equal to the integral of negative 32t plus 80 dt, which is going to be equal to negative 16t squared plus 80t plus c. Well, at s of 2.5, we know, actually at this point, the initial position is 0. So c is going to be 0 because we're on the ground, right? So our initial position there is 0. So s of 2.5 is negative 16 times 2.5 squared plus 80 times 2.5, which is going to equal 100 feet. So at s of 2.5, they're 100 feet into the air. All right? So let's talk a little bit more about what's going on here. So a person races away from the scene of a crime in a car. They accelerate from 0 to 60 miles per hour in 4 seconds. How much ground did they cover in those 4 seconds? Well, our acceleration, a of t, is going to be our change, right? So 60 minus 0 over 4 minus 0, which is going to be equal to 15 miles per 1 hour. Oops, 1 hour. And we want to convert that into seconds, right? So we've got 1 hour is equal to 3,600 seconds, and 5,280 miles is equal to, feet is equal to 1 mile. So that's going to equal, let me calculate this. I'm going to pause and calculate. Okay, I calculated. That is equal to 22 feet per second squared. Okay? Well, we know that at 0, we're at 0, right? At time t equals 0, we're at 0, what am I saying here? Velocity, right? And at 4 seconds, we're at 60 miles per hour. That's important to know as well. Actually, maybe it's not that important. Well, anyway, ignore it for the moment. But we're going to find our position. So first, we found our acceleration. First, we need to find our velocity. So v of t is going to be equal to the integral of 22 dt. So that's going to equal 22t plus c. Okay. Ooh, hey, this is when I need that information. So v of t equals, so v of 0 is equal to 0 plus c, which equals 0. So c equals 0. Boom. So v of t is actually equal to 22t. Then we want to find s of t, because we're trying to find that distance that we covered, right? So s of t is going to be the integral of 22t dt. So that's going to be equal to 22 times 1/2 t squared plus c. So this is s of t is equal to 11t squared plus c. Then we can say s of 4 is equal to 11 times 4 squared is 16 plus c, and that's going to equal 60, right? 11 times 16 is 176 plus c equals, oops, hold on a minute. Okay, I realized that I jumped the gun here. I'm going to erase this. So I've got s of t is equal to 11t squared plus c. And what I really need to do is use 0 again to find c. And so 11t squared plus c equals 0. That's going to be our position, right, at 0, which actually makes sense. So c is going to be equal to 0, and I should have put a 0 there. So s of t is really equal to 11t squared. And now we're going to find the distance after 4 seconds when they've sped away. So s of 4 is equal to 11 times 16, which equals 176. And I think we said feet. All right, feet per second. Okay? One final problem here to figure out. The criminal, in addition to being charged for the crime, was ticketed for driving over 100 miles per hour. They covered a distance of 5,000 feet over 30 seconds before crashing. How do we know that a ticket is justified? So this actually is bringing us back to mean value theorem, right? So we know that our average velocity is 5,000 feet over 30 seconds, okay? So let's cover this for over 100 miles per hour. Well, we need to convert this here. So we know that 1 mile contains 5,280 feet. We've talked about that before. And we know that there are 3,600 seconds in 1 hour. And if we calculate that, did I do it right? Boom, looks like I did. This is about 113.636 miles per hour. Okay, so that is our average velocity. Our average velocity is 5,000 feet over 30 seconds, or 113.636 miles per hour. So yes, they do deserve a ticket because by the mean value theorem, he has been traveling over 100 miles per hour at some point from 0 to t to 30 seconds, right? Okay, a nice way to tie all of that in. Hopefully this makes sense. There's a lot of position, velocity, acceleration, a lot of integration, and seeing how those are connected. And differential equations do play into it as well, but hopefully a lot is very familiar to you. Please leave any questions in the comments. I'll see you in class. Bye!